Hello, welcome to this video on water shaders. So I've got my ocean here. It reflects light, as you can see over here. It refracts, it has noise. It has foam. Still not, everything that I want it to be, but, better than, a lot of things that you might have seen, not too long ago. So I just wanted to, briefly cover, how the water works. It's in a my Rust-based engine, which, I've built in C++, and that's fantastic. I already had so much engine code in Rust, however, so this was a natural fit for that reason, at least. I also happen to really like wgpu. It's just, the right balance between verbosity and complexity while still having enough options and capabilities. So yeah, anyways, this here is the water config. This basically describes most of the parameters for the water. So this enables really easy adjustments to these parameters from outside of the shader. So, you could have hot reloading of the shader, but that's a whole nother task, and it doesn't fit very well with my application requirements. So I'm looking for something where the user can edit the values, not necessarily where they need to go into the shader and update it. So anyways, I really like this. This gives me the ability to change things very easily. We have the default set up here. Standard Rust capability. This covers, the various variables we have for the colors, player position. So this is dynamically updated to enable interaction. We have ripples, which are also related to player interaction. We have the foam here. We have sparkles and subsurface, which is basically how does it look the deeper the water is. And the Fresno, which is basically how does it look from an angle. We also have the waves, which are basically interleaved and combined within the shader to produce some variation. The bigger waves tend to move slower, as you can see. Anyhow, now if we come to the water plane itself, now that we're in the water plane, we're going to want to do a few different things. So first of all, we want to define our struct, and this is going to help us plan for what we always need: a vertex and an index buffer to define the geometry. What we need in this case is a separate pipeline for the water, so we can have our separate water shaders. And we have things that need to be updated dynamically, like the time buffer, And we also have the landscape bind group, which essentially allows us to provide landscape texture data, the height map, to the water shader. This will enable us to detect the shoreline automatically, rather than having to provide some sort of like water mask which describes where the shoreline is. So we also have the water config and the ability to provide that to the shader. Now, what we do to start off is we basically create the bind group layout and the bind group on the landscape, which is necessary for providing the texture data to the shader about the landscape. We could get into this. It's pretty straightforward for wgpu stuff, but I will leave the landscape for another time. Here we basically just load our shader right here in the same directory, set up our time buffer, the other necessary things. We set up the config, bind group, layout, etc. Then we generate our grid mesh, which is basically just a mesh for the ocean. We set where we want it. So this is relative to the current landscape. This is technically hard-coded right now. I'd like this to be configurable later on. Same with the size, because you could have different size landscapes, different sized oceans. Grid resolution tends to help a little bit with the quality, but it's not the only determining factor. You know, the way that you do your shader is going to have a lot to do with the quality of it. So anyways, yep, we set up our pipeline layout. You're only allowed up to 4 bind group layouts per pipeline layout on the web, at least. So just something to keep in mind. That's why we have so much data packed into one buffer, but you know, that's okay, not a problem. Then we set up our pipeline. The fragment targets a number of things necessary for the PBR and deferred rendering. So it's not just your colors, it's like other properties, like your metallic or your roughness. So anyways, besides that, it's pretty standard pipeline, I would say. We have a couple of convenience functions here, just for writing to the buffers and updating the config values. This is how we generate our grid mesh. Pretty standard stuff, just taking the size and the resolution and basically generating vertices at a regular interval. And indices tend to go in a certain order for each triangle. So you have 2 triangles for a quad. So that's what's going on there. And you know, pretty straightforward overall. You know, this water plane, the Rust code is pretty simple. And we just bind things when we're drawing in the pipeline. So that brings us to the water shader. Now in the water shader, we have basically all the things that, you know, we set up in the Rust code. So we have our camera uniform, which we bound. We didn't set it up in the Rust code, but we passed it in when we created the water plane. And we have the time. We also have that landscape data. We have our config uniform. We also have our outputs. So this is the PBR material, which contains the other properties I was referring to. This is the albedo, which is mainly the color, the actual color information that you would normally send through. This is normal information, just the direction of a vertice, basically which way is it facing. And this is the position. So yeah, we have all the outputs set up here and the inputs. We have more helper functions here. This is just for sampling the landscape texture data. So right now it's hard-coded on the Y value here. It's also hard-coded on the size and the actual height. But, you know, pretty straightforward, pretty simple to sample the reds out of a texture, and there you go. You have, once you have the max height and you multiply that, you basically have your height value. There's also here a number of noise functions. These I don't have full thorough understanding for the math here, but these are powerful for mainly for the fragment shader when we're doing colors, things like that. I'm not sure if we're using it in the Gerstner wave, and it doesn't look like it. So I think it's just for the fragment shader. And that's how we get textures on the surface and that sort of thing without having to supply, an actual texture. Here's the Gerstner wave. This is technically a parametric curve. So it kind of moves up and down, sort of like you would expect a wave to do. There's a lot of similarities between the wave and the wave normal. They're very similar. If you look at the code here, but of course they are, right? Probably could make this a little more dry, but it works. Anyways, here's a vertex shader, which of course basically just determines the position of vertices for the most part. So we're generating our waves here using our config values, and then we are basically interleaving or merging these, and we prepare our normal data, which for the most part just gets sent. We calculate tangent and bit tangent, and we send that out to the fragment shader. And we also handle player interaction right here. So overall, not incredibly complex. It looks sort of complex, but this, these variables are very short. That's for D, but it's direction, right? So Q, steepness. So not exactly the best variable names there, and it makes it look, a lot more complex. But this is just standard equations. These are just standard ways of determining where something belongs. Anyways, we come down to our fragment shader, and this has, this is probably the portion of the shader that I understand the least. I'd like to say that I understand it 100%, but I really don't. We use the noise functions to produce these normals which help produce ultimately the sparkles. So if we follow the detail world normal, it does this normal here, which brings down into the reflections, which ultimately leads down into the sparkles, as you can see. So it's all interconnected, and of course the direction that something is facing will have a lot to do with the sparkles. So we have a hard-coded sun in here currently, and we handle our foam based on our parameters, and do our subsurface, have a little ambient just for guaranteed light, and there you go. It's all brought together into a final color right here. So yeah, I can't go through every line here. It's just too involved to go through every line in detail. But there's a lot of patterns here. Recurring use of smooth step. Use of other functions like reflect. Really convenient function. But hopefully you have like a better idea for how this shader works, how it's connected, and maybe depending on where you're at with your math skills, you can write something even better. I would say basically everything here is fair game for experimentation. If you want to adjust this value here, or this value here, or this value here, I mean, it could be anything. And you can get a different look. It may not be as realistic, but could be better for you. Anyways, that is the gist of my water system. I hope that you got something out of this.